Welcome to Precalculus video 6D. We're going to understand the difference between and versus or, and there are 5 boxes, so let's get going right away. The first idea that we have to understand is what mutually exclusive means. You're going to hear this word a lot in this section, so we have to understand what it means. And here's the definition. It's two events that cannot occur at the same time. Those are said to be mutually exclusive. So two events that cannot occur at the same time. Okay, here are some examples that are mutually exclusive. You cannot have a red spade. Let's say I was picking one card from a deck of cards. There's no way I could pick a red spade because spades are black. So those are mutually exclusive. Here's another one. You can't turn left and right at the same time. There's no way that those two events can happen at the same time, so they are mutually exclusive. Here's a third one. You cannot be sitting and standing at the same time. That's another mutually exclusive event. Those are two. Here is an event that is not mutually exclusive, right? We could turn left and sing at the same time because those two events can happen at the same time, so therefore they are not mutually exclusive. Okay, box number 2 is an example. We're going to talk about or probabilities with mutually exclusive events. So here's the thing we want to understand. If we have two events, A and B, and they are mutually exclusive, meaning that there's no way they can happen at the same time, then the probability of getting A or B is just the addition of the probability of A with the probability of B. So that's an important box for you guys to write down in your notes. Okay, let's do this quick example to illustrate the point. Let's say I have a deck of cards and I am going to draw a card from this deck of cards of 52, and I want to know the probability of getting a king or a queen, a king or a queen. Well, first of all, you should realize that there's no way that I could draw a king and a queen at the same time. So these are mutually exclusive events, so I'm covered there. So according to the definition, it is the probability of a king plus the probability of a queen. So I need to figure out the individual probabilities and then add them together. Well, the probability of getting a king is 4 out of 52. There are 4 kings out of a deck, and there are 52 cards. The probability of getting a queen is also 4 out of 52 because there are 4 queens in the deck. And I just simply add these together to get 8 out of 52. Now we always want to reduce our fractions in probabilities, so 8 out of 52 simply reduces to 2 out of 13, and you have come up with the probability. Box number 3 is a U try. I want you guys to figure out the probability of rolling a 4 or a 5 when you roll a single die. Hopefully you got the right answer of 1/3. Here's how I did it. The probability of getting a 4 or a 5, well, these are mutually exclusive events because they cannot happen at the same time. So therefore, I take the probability of 4 and I add it to the probability of getting a 5. That's just 1/6 plus 1/6. That makes 2/6, and that reduces to 1/3. Box number 4 is an important box because we're going to talk about or probabilities when the events are not mutually exclusive. So that means that some of these events can happen together at the same time. And what ends up happening is we double count them if we don't subtract them from our original answer. So let's walk through this example to illustrate the point. We're going to draw a card from a single deck of 52, and I want to know the probability of getting a diamond or a picture card. Now, a picture card are the jacks, the queens, and the kings, okay? The jacks, queens, and kings. So I want to know the probability of getting a diamond or a picture card. Well, you can see from this picture over here, okay, I have some cards that are diamonds, and I have some cards that are pictures, and then I have some cards that are both diamonds and pictures at the same time. Those are these right here. These are the ones in the middle right here. Okay, so they get double counted in the set, right? So these belong to this set, and at the same time, these picture cards belong to this set because they are not mutually exclusive, meaning they can happen at the same time. So the way that we deal with this is we figure out the probability of a diamond, and then we add it to the probability of a picture card, and then we subtract the probability of both, of a diamond and a picture card. So this is the new part that we have to be very aware of whenever we are dealing with events that are not mutually exclusive. Okay, So the probability of getting a diamond, well, there's 13 diamonds out of 52 cards. All right. Probability of getting a picture, well, there are 12. If you count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 picture cards out of 52. But now we need to subtract all of the ones that are counted in both sets, right? So those would be these right here. This would be 3 out of 52 because those 3 cards are both diamonds and pictures at the same time. So we add this together, we get 13 plus 12 minus 3 over the common denominator of 52, and we end up with 22 out of 52, which then reduces to 11 over 26. So again, whenever we have events that are not mutually exclusive, we have to subtract those because we end up double counting them. Okay, the last box is talking about AND probabilities with independent events. In the other boxes, we talked about OR probabilities, and now we're going to talk about AND probabilities, okay? First thing you have to understand are what independent events are, and basically two independent events are events such that one outcome does not affect the other outcome. Okay, so nothing I do in the first event is going to have any effect on the second event. That's what it means to be independent. Okay, let's take a look at an example here. We have a roulette reel with 38 numbers, 1 through 36, and then a 0 and a double 0. Okay, of the 38 compartments, 18 are black, 18 are red, and 2 are green. A player has the dealer spin the wheel and a small ball in the opposite direction. As the ball slows to a stop, it can land equally in any one of the 38 numbered slots, okay? So it's kind of a fun thing to do. So as you can see over here, like the ball is on the red 3 right now, okay? So find the probability of red occurring 2 consecutive plays in a row. So basically, we want the probability of getting a red and then the probability of getting a red again. So probability of getting a red and then another probability of getting a red. Okay, well, if my events are independent, and these are because there's one outcome does not affect the other, then according to my little rule here, the word AND means to simply multiply the 2 respective events together. So this is going to be the probability of red multiplied again by the probability of a red. So the word AND means multiply for us, okay? So let's figure out what's the probability of getting a red. The probability of getting a red here, well, it says here there are 18 red out of the 38. So this is going to be 18 out of 38. 18 out of 38. And then the probability of getting a red again is just 18 out of 38. And since we are trying to figure out the probability of getting a red and another red, we're going to end up multiplying these 2 together. So remember, when you multiply fractions, you multiply straight across, and you end up with something when it reduces down of 81 over 361 once you reduce the fraction, okay? So in this case, when we're talking about AND probabilities with independent events, I need you to remember that when you see the word AND, it means to multiply.